So when I was Googling this topic after reading your book, The Origin of Language, just Google, what is the origin of language? And then, of course, I had to go over and ask ChatGPT, because that's what you do in 2025. And it basically said that there's numerous theories and they're not actually sure how language originated in humans. And I'm thinking, like, in 2025, I thought we have all this technology and all this research, and to find out that we don't even know how language, which is pretty central to humanity and civilization, I found that to be quite interesting. So what is the origin of language?
Well, of course, you've read my book, so you know what the origin of language is, because, of course, I am right. Now, but on a more serious note, the issue is that the tissues that we need that allow us to speak don't fossilize because they're all soft. So we don't have any fossil evidence for when humans, and I'm speaking about all the different species that came before us, we have no clue really, or no hard evidence in the form of fossils that allow us to say, well, this species could speak, this one couldn't speak. So it's all circumstantial evidence when language started in the first place. And that then makes it even more difficult to come up with the origin of language. So why did we start to speak in the first place? So I think I remember listening to a podcast, and I can't remember which one it was, but they interviewed Frans de Waal, the famous primatologist who died about a year ago, I think. So he made a very strong claim in that podcast that not chimpanzees, that Homo neanderthalensis could speak. And I was actually quite surprised by that strong statement, because there's no evidence. And in fact, I would claim, based on data that other people collected, that Homo neanderthalensis could not speak at all because their neck was too short and their face is too different from our face to allow the construction of this large vocal cavity that we have, and the position of the larynx would have sat too deep down in their throat, which would have interfered with swallowing. Then there's also circumstantial evidence from epigenetics, which showed that they had a different epigenetic profile, meaning epigenetics allows you to see which kind of genes were turned on, so they were functioning, and which one turned off, they're not functioning. And that seemed to indicate that there's big changes in the epigenome, as they call it, between chimpanzees, modern humans, and Neanderthals. That seems to indicate that we have a specific set of genes that are expressed in our throat. And again, that seems to indicate that that has something to do with language. So it's a lot of circumstantial evidence, I think, that points to the fact that only Homo sapiens was ever able to speak. But then, of course, that still doesn't answer the question why we came to speak in the first place. And that is what I try to answer in my book. I also have to say that when I started working on this book, it was never my intention to answer the question why we came to speak and when we came to speak. That sort of just came out when I put all the different pieces of the puzzle together, because I was trying to understand what were the major changes in our evolutionary history that made us what we are now. I came to the realization, well, we had to learn to speak in a much more precise way once we started producing those completely useless and dependent babies that require very sophisticated social structure to allow them to be raised. So it's, as I said, I didn't look for this was not the question I was trying to answer. It just sort of came out as a logical conclusion.
When did humans start speaking? I was reading this article from 2024 in Nature, written by Harvard linguist, and there was another linguist from MIT and Cal, and they had a range of between 100,000 and 1 million years ago. I mean, talk about a factor of 10. I mean, that doesn't really give you too good of a time frame, so to speak. Do you think that is it 100 to 1 million years, or 100,000 to 1 million years ago? When do you think that was? And what you're talking about, how humans in the book, even to this day, choke. on food and whatnot, and it's because of how the face is structured with the ability to speak. So I would imagine you can go back and have a pretty good idea just based on how the jaw, the tongue, and things like that changed over time. But is it that even unknown to this day, where we're thinking it's 100,000 or 1,000,000 years ago?
Well, there's three pieces of evidence again that sort of indicate it's about 150, 200,000 years ago. So that coincides with modern humans in the sense that humans are modern. That if you would find a skull of a human about 150,000 years old, the skull would be indistinguishable from a human now. So we haven't changed in that time. There was a lot of changes before then. So I think our species is about 300,000 years old. So if you look at a skull again of 300,000 years ago, it would look very different from a skull of 150,000 years ago. So in those 150,000 years, a lot of things have changed to the skull and the neck. So that's one piece of evidence that something major happened 150,000 years ago. Then there's another piece of evidence which you can find if you look at things like art, technology that was made, and evidence of trade. So all these three things, we find evidence which is about that it's about 150,000 years old. So trade is important. So how do we find evidence for trade? That stuff was made from materials that weren't present in the place where the piece of technology or art or something was found. So that means that materials must have been traded from somewhere else. Now, in order to do trade, you have to have some sort of formal communication or precise communication. The same with particular technologies that were so complex that you couldn't learn to make them by just observing the person who is making them. So again, it seems to indicate a form of direct teaching or direct instruction, which is pretty difficult to do if you can't talk. So you try and explain something to someone without using words. That makes it much more difficult. So this again is circumstantial evidence that there was a more sophisticated form of communication present about 150,000 years ago. Then the last piece of evidence, which I think is pretty cool. So I don't know if you've ever thought about how people measure the time between sharing a common ancestor and two different species, say. So humans and chimpanzees shared a common ancestor about 6 million years ago. So about 6 million years is a divergence between the lineage that led to humans and the lineage that led to chimpanzees. Now they call it a molecular clock. You can estimate how long it's been since those two species had a common ancestor by looking at the accumulation of mutations. Because the longer the period between being the same species, say, the more unique accumulations of unique mutations you have accumulated. So you can basically sort of start counting back. You can do the same with the evolution of languages, apparently. So, of course, now we have, I don't know, hundreds, thousands, maybe different languages on the planet. And you can map the complexity of the language with the migration of the humans. So humans evolved in Africa. The African languages have more phonemes, so they're more complex. You can say that they have a large number of mutations. Now, when humans left Africa, they only took with them a subset of the phonemes that were present in the African population, simply because there were fewer people that moved out of Africa. So you get what they call a genetic bottleneck. So you have a subsample of those original phonemes. Now, these people, of course, moved and moved and moved and moved and moved again. And now the last land masses that were colonized by humans are in parts of Oceania and parts of the Americas. And you can compare the complexity of the later language groups to the original language groups and then sort of use it as a molecular clock to estimate how long the separation has been between, say, the original language you find in Africa and the more derived ones. And that too came to the conclusion that language probably evolved about 150,000 years ago. So the three pieces of circumstantial evidence converge on that 150,000 years. So I don't know where they get the 100 million or the million from, but that seems extremely unlikely.
Yeah, in the book, you talk about language as a virus adapting to a child's brain. And you just mentioned about how the simpler the language, the more, I guess you could say, of a virus it is. If children can learn it, I thought that concept was interesting. Can you talk about that?
Yes, I have to say the language as a virus is not my original idea. But when I read it, I thought this just makes such a lot of sense. Because one thing that people always struggled with is understanding why babies or children are so good at picking up language. It doesn't matter where they're born, and they can even be raised bilingually or trilingually if they are exposed to these languages from a very early age. You don't have to teach them grammar. They just pick it up. So what is it about language, or what is it about the brain that makes it so easy for young children to learn it? I was talking to someone, and he lived in Japan for 5 years, and he tried to learn Japanese. And he said it was so annoying that these 5-year-old kids whose Japanese, they've been learning to speak Japanese for as long as he had, and they just pick it up, and he couldn't. And for a long time, the idea was that there's sort of a sensitive period in our brain that switches off after about, depending on whom you ask, between the age of 4 and 7. So that we have this sensitive part in our brain that allows us to understand language intuitively, but later on that switches off, and then it becomes much more difficult to learn language, which seems a bit strange, because why would a brain just switch something off, which is actually quite useful? So therefore, this idea of language as a virus is so elegant, I think, because the idea is that language will go extinct if it can't be transmitted from brain to brain. The best way to transmit language from brain to brain is to infect a baby's child, or a baby's brain or a child's brain, because they are the first ones to take that language and spread it further, because they turn into adults, speaking adults, and then they will spread the language. So for language, it's very important that it's structured in such a way that it's really easy for baby brains, for children brains, to pick it up. Now, this may sound a little bit creepy, because it almost gives the impression that language is a thing which is conscious, and it makes a decision, well, I'm going to structure myself in such a way that I'm going to be able to be learned by children. But of course, that's not how it works. And there's beautiful evidence also from pidgin languages. So pidgin is a language that people use if they don't have a common language. So they start mushing up all the words, etc., to come up with a way to communicate with each other without having a common language. Now, pidgin has no grammar. There's no structure. But pidgin turns into, if these people stay together, then pidgin will turn into creole, which is a language in the sense that it has a structure. And children are essential in turning pidgin into creole, which is an official language according to linguists. And apparently all creoles have a very similar grammatical structure. And that is, again, because it comes from the brain of children. So children's brain have something special that allows them to quickly learn the grammatical rules of all languages. So now, how does it fit in with my idea of why we speak in the first place? And I have to go back a little bit then. So as I said, I started writing the book because I wanted to understand human evolution. I wanted to be able to link events that happen at the molecular genetic level to the individual level. So how can you have changes? How do changes, small changes often at the genetic level, lead to large levels, large changes at the individual level? And then I found out, well, there's all these weird things that happened in our evolutionary history. Most of them are basically mistakes. And then somehow natural selection allowed us to get away with it. An example is one of the first things that happened when we separated from the common ancestor with chimpanzees is that two of our chromosomes got stuck together. So now we no longer have two separate, they're stuck together. So we have one long chromosome. That meant we could no longer mate with individuals that had the two separate chromosomes. So you get a small mating population, and that small group of individuals can basically evolve into something else, say. Now, then we started coming down from the trees, decided that it was no longer fun to walk on four legs and to swing up in trees. Let's walk on two legs. And that forced huge changes to the skeleton. One big change was the narrowing of the pelvis. But also, now you have your hands free to do something useful with them. But it also means if you have a baby, your hands are no longer useful for anything else other than carrying your baby, because you can't put them on your back anymore because they'll just fall off because you're standing upright. So that made incipient species, so this is about 4 million years ago, extremely vulnerable. They evolved in Africa. Africa is full of large predators, it still is. But they were even worse then. Massive creatures that will just make a snack out of these little humans. So our ancestors were forced to stick together because as I said, first off, you can't run fast if you have two legs. If you're holding a baby, you can't do anything useful. And the other thing is it was very difficult for babies to be born without the mum having help because of a funny twist to the pelvis, which has everything to do again with walking upright. Anyway, fast forward. So our early ancestors were already social. If you're social, you have to have some form of communication. And I know this because I studied ants and bees for most of my academic career. They all have different forms of communication. And the more complex their society is, the more complex their primitive form of communication is. So all social animals have some form of communication. So that was already there. Then all these other weird things happened, which culminated in a weird mutation, which allowed our brain to grow. So about between 300 and 150,000 years ago, this mutation happened. The brain ballooned, which meant that either that incipient species or that early human went extinct because its brain was too big, couldn't fit in the skull, or the skull adapted. Well, that's what the skull did. It adapted to fit in that large brain. So now we have humans with an enormous head. You don't really see it in you and me, but if you look at a baby, you can tell that there's just something seriously wrong with these babies. Their heads are just way too big for their bodies, which makes them look extremely cute. But now there's a pregnant mother who has a baby in her that's growing this massive brain. Brain tissue is the most expensive tissue you can imagine. So it costs a lot of energy to grow that brain in utero. But also, if that brain or if that head gets so big because of the narrow pelvis that you need in order to be able to walk upright, the baby would not be able to be born if the pregnancy would be longer than 9 months. So human females were forced to give birth to babies that are basically not yet ready. If you compare a chimpanzee baby and a human baby, the chimpanzee's baby's brain is much bigger, is a much larger proportion of the adult brain than the human brain, than the brain of the human baby. It's I think I'm a bit rusty on the numbers. I think a human baby's brain is only about 25% of the adult size. And if you've ever looked at a newborn baby, they're totally useless and they stay totally useless for a very long time. So this increase in brain size, the walking on two legs, basically resulted in these seriously underbaked babies that take about 15 years before they're able to collect the amount of resources they need to sustain themselves. So that means for 15 years, they have to be supported by others. So you have these babies being born in what was already a social environment, which then selected for even more precise forms of communication, which, as a funny twist of fate, was possible because of this change to the skull. This change to the skull that was required to fit in the large brain also changed the throat and the whole vocal system that allows more precise speech. Now, that was a very long answer to your question. I hope it still made sense.
You mentioned one of your friends that was in Japan learning Japanese, learning a second language. And you didn't really talk too much in the book about second language. I was kind of curious, if there was any hacks or whatever, because I think there's a lot of people always trying to learn a second language. I think in a podcast I heard that you were you were trying to learn Spanish right now. But I went to Costa Rica for 6 months, and I was in a Spanish immersion school, and I was always fascinated because I would talk to classmates in this Spanish immersion school that would be like, yeah, I learned more in 2 weeks in Spanish immersion school than I did in 8 years, and between college and high school. And it's because you're actually immersed in it. And I kind of got pretty deep into it. And I read a lot of books. I've read a lot of linguistics, like how can I learn a second language faster? And I read a lot of Dr. Stephen Krashen, who's a foremost expert on how to acquire second, third, fourth, fifth languages. And he basically says you need to learn your second, third, fourth, fifth language, etc., the exact same way you learn your first. However, how in school they generally, you take your language, so for us, say English, and then you reverse engineer it. So you're not actually learning a new language, you're just kind of translating. And for myself, I actually found myself reducing my class time and increasing the time I spent with the host family and just watching TV, going out and actually having to be in the environment. And it's actually pretty amazing how fast you pick it up. And like Dr. Stephen Krashen says, an adult picks up a second language faster than a child. Of course, like as you're mentioning, the child doesn't have the accent, where as an adult, you pretty much always have the accent. I mean, they have different levels of fluency, like the top level of fluency, there's no accent. You understand humor, things like that, which even if you're really good at a foreign language, you might not actually get rid of the accent. You might not understand certain types of jokes. But I kind of was thinking your friend probably maybe doing it wrong. Like you just need to put yourself into the mind of a kid again and not reverse engineer your language. Just go hang out with locals that don't speak any language that you speak and just sit there and observe them like you did when you were a kid. But I think for a lot of people, it's kind of hard to go back to being a toddler again. But that, like for me, that was the easiest way that I learned as well. You just find yourself one day speaking words you don't even know what you're speaking at first because you're not actually translating.
I think you're right. So I just came back from Argentina, which is one of the reasons why I'm started to learn Spanish. Well, I wanted to learn Spanish for a long time anyway. So I spent, I think it was 250 days on Duolingo doing Spanish lessons every day, at least, I don't know how long for. And then you get to Argentina and I see my friend there and he says, well, we don't use this in Argentina. We don't use this. We don't say this. And well, but then it's all been useless. I should have just been here and what you say, just be immersed, be forced to speak. That's the one thing. Because then you make silly mistakes, but it doesn't matter because the whole point is that you try to communicate. And that's what the kids do too. They have no clue what the rules are when they start. They just start saying something because that's what they heard. And if it works, it works. And if it doesn't work, then you come up with something else. So, yeah, you're totally right. But I wouldn't say that everyone should give up on trying to learn another language from an app or an instruction book or whatever, because you still need your vocabulary too, which will help you when you then immerse yourself. But I agree. Just immerse yourself. What is it? Necessity is the mother of all inventions. If you have to speak, you will find a way to communicate with people.
Yeah, exactly. I mean, if you're forced to use it, I mean, I think one of the issues, especially when you speak English, is that there's a lot of, especially when you're talking about being in Argentina. I mean, I was in Central South America for a while, but a lot of the Spanish speakers want to work on their English. So then they see you and it's like, oh, well, this is an opportunity to practice with a native speaker of English. So you're trying to speak in Spanish and then they're trying to speak back to you in English because they have an opportunity to practice their English, where it's like, oh no, I want to get immersed in it, you know?
But then goes to Argentina because many people don't speak English, I've noticed.
Yeah, it really depends. I mean, that'd be like if you're in a touristy area, depending where you're at, all of a sudden people speak Spanish. Then you go to a place that's not quite as touristy or maybe a little bit off the beaten path, and then no one speaks English. So then you get that opportunity to use it, which certainly is the way to really get more higher level of fluency much quicker.
Yep. But you're also right about the reverse engineering of a language. So because that is what you do when you try to learn language initially, I think. You're thinking your own language, which for me is a bit complicated because English is my second language. I also learned German. So I was trying to speak Spanish yesterday, and then I realized that all these German words are coming back into my mind, which are totally useless. I have to try and speak Spanish. So, and that's because, yeah, as you say, you're trying to think of the word in your own language before you try to think of the word in Spanish in this case, which is what you shouldn't be doing. Just forget about the other languages and try to communicate. Much more easily said, of course.
Yeah, like Dr. Stephen Krashen says, like the best way to learn is just put on a really easy TV show. Like let's say you're trying to learn Spanish, so it'd be like a TV show for kids in Spanish with Spanish subtitles. That way you're listening to the Spanish, you're reading the Spanish, and then it's better not to have a cartoon, because if you have a cartoon, you're not seeing the mouths move. So it's like actually have like real humans. And then, start at a really low level, and then eventually like soap operas or something like that is good, where they're like being overly dramatic. They're overacting. So you can kind of figure out what's going on just by the body language, is it's overemphasized. And then you eventually progress to maybe like a documentary or something like that. But he says if teachers were to do that, you wouldn't need a teacher. So they have to have tests and they need to reverse engineer this stuff in order to teach a course. So, he's like, explain to your parents why you're watching soap operas all day in Spanish, 501 or whatever, like it'd be pretty hard sell.
Yeah, that's interesting concept, but it does make sense.
So in your book, you talk a little bit about Steven Pinker and Noam Chomsky, and I think a lot of people maybe know Noam Chomsky more for his kind of, I say activism later in his life, but in his younger years, he was one of the foremost linguists on the planet. Steven Pinker obviously is a famous linguist as well. And you talk a little bit about their theories and how you differ on those two fairly prominent linguists. So you want to talk about Steven Pinker and Noam Chomsky and their theories and how you differ a little bit?
Yeah, well, Steven Pinker is a little bit unfair because the publishers put his name in deliberately in the blurb to attract attention. Because I don't think I really disagree with anything Stephen has written about language. But then again, I also don't remember him saying anything about the origin of language. I mean, and I haven't read all his books either, but there's a sense of style, how language is important because of the way you use the structure of the sentences, etc. The way I use them in a book is because of his hilarious way in which he starts a chapter in one of his books, which uses the titles from the Sun. Yeah, I think it's the Sun, one of those gossipy newspapers from the 80s, I think, which basically says baby born speaking or something, where people claim that there actually been multiple claims of babies being born, being able to speak proper sentences, which of course is totally BS because they can't. So that's the way I use Steven Pinker in the book. I don't actually criticize any of his work on linguistics. Noam Chomsky is a different matter. So he was a very strong proponent of the idea that there's an innate language acquisition device. So he tried to argue that because children are so good at picking up language, there must be some sort of genetic mutation that allowed us humans and us humans alone to grasp language, and that language could not be explained by natural selection because it's too complex. And actually, Alfred Russel Wallace, the co-discoverer of evolution through natural selection, in his later life became a little weird. He started to have some very strange ideas. And one of the idea he had later in life was that language cannot be explained by natural selection because it's too complex. And it's sort of similar to claims that people have made that the eye, for example, the compound eye, cannot be explained by natural selection because it's too complex. If you take one thing away, then the eye doesn't work anymore. So how can it then be the result of small changes that eventually lead to the eye? So this is always one of the examples that being used by creationists to explain that we need something like God to create the eye, etc. Now, Chomsky and Wallace never said that God was required for language. So don't get me wrong. I don't want to say that they're a creationist or that Wallace was a creationist. But they did say that language is too complex to explain in a gradual sense. It has to basically come from nowhere. Well, anything that's supposed to come from nowhere, I find a bit hard. So from Chomsky's language acquisition device, people then started to think that there must be a gene for language. So that in our species, a mutation happened that allowed language to evolve. What that gene really did, no one was concerned about it, but the idea was that language acquisition is only possible because of a particular mutation. Now then, in the 70s or 80s, I can't remember, people thought that they found the language gene in the form of FOXP2. Why did they think this? Because they found this family in the UK, which is a large family in which many of the family members had speech problems. They were not retarded or anything, so they were of average intelligence, but they could not construct sentences that make sense. They didn't understand language, they just couldn't vocalize language. And that then later was traced back to a particular part in their genome. And then, of course, the claim was made that was the language gene. Well, that turned out not to be true because FOXP2 is also present in Neanderthals. But it's basically a gene that's important for vocalization. You can find it in mice, you can find it in birds, you can find it in almost anything. It's a very old gene. So that was off the table, but it would have been the explanation for Chomsky's language acquisition device. So I disagree with Chomsky in the sense that and with Wallace, because I think language can be explained by natural selection by basically putting pressure on the organisms that are already social, that already have a particular form of communication, to make the communication more precise. But in order for that to work on communication, let's not call it language yet, and communication, there has to be a very strong selection pressure. Now, natural selection works on traits that give the bearer of that trait an evolutionary leg up in the sense that they are then able, because they have the trait, to produce more offspring or to look after the offspring better so that the offspring has a higher probability of surviving and reproducing themselves. So what is more important than to have a mechanism, precise communication, to ensure that your extremely dependent offspring will live to reproduce themselves? So the twofold change that happened when our brain expanded that led to completely dependent offspring dependent for a very long time, also allowed precise communication. So then you get this positive feedback. The more precise your communication, the better you're able to look after those dependent offspring, the better those offspring are in picking up language because they are born with a very neuroplastic brain. Language then adapts to the neuroplastic brain. The brain gets better at language. And you basically, as I said, you get this positive feedback loop, which then makes language more precise, makes the babies more better to acquire that language. And then in the end, you're speaking to me in your language. I'm speaking to you in my second language from the other side of the planet. And here we are.
Your background is evolutionary biology and behavior ecology. So, for the vast majority of your career, what did you study? Like, reading some of your papers, you spent a lot of time with bees, with other insects, and then like in one of the other podcasts that I referenced that I mentioned that I saw, you basically said, I think that you wanted to write a book that was accessible to the general population instead of having, 3 academics read some of your papers, which I guess is probably pretty common in academia where there's so many papers and how many people are actually reading them. Especially now, you probably have even the people that are accepting it are running it through Chat GPT, having Chat make the decision like, oh, should I put this paper in the publication or not? But can you I guess the question is like, because you talk a lot about evolution in the book, not even related to language, but what was some of your earlier research focused on?
So I did a lot of work on honeybees, as you said, and often people think of one species, which is the Western honeybee, that's also introduced into Australia, it's introduced into the United States, but is not native to Australia, it's not native to the United States, it's native to Africa and Europe. But in Southeast Asia, there are about 10 or 11 different species of honeybee. And they all have slightly different, they're all social, because otherwise there wouldn't be a honeybee. They all have this dance language, which is not really a language, but we're like using the word language. It's a way by which they communicate about the location of either a nesting site or a forage site. So I spend a lot of time deciphering this dance language because the cute thing about it is you can film the bees while they're doing their dancing, and then you can just at your leisure back in the lab, you can decipher the dance because we know what the dance basically means. So there's particular parts of the dance that you can measure, and then you basically know where the bees are trying to lead their nest mates to. Now, at some stage, I got interested in how honeybees select a new nest site. Now, these different species of bees can be put into 3 different categories. We have the one like the one we have in the US and in Australia and in Europe and Africa. They live in hollows, in tree hollows. Now, these tree hollows are hard to find. Then you have the open nesting species. They all live in Southeast Asia, and they basically find a little twig, and then they make a single comb nest that hangs down from the twig. And the nests are about this big. They're the dwarf bees, and there are multiple species of them too. Then there's the other open nesting species. They are the giant honeybees, and they make nests which are meters across, very heavy. They're big bees, and they need either a big structure, heavy, that's strong enough to hold their comb, their nest, or a massive tree. And they often cluster together because these structures that are strong enough to hold their nests are quite rare. So if you now imagine that a bee colony is trying to find a new place to nest, most of the bees just sit there and wait for instructions. And then we have some bees, we call them scouts. They go out and search the environment for a new potential nest site. If they find something that's suitable, they go back to the bees and do this dance in which they basically say, if you fly this way relative to the sun for that distance, then you will find something that I think is suitable to nest in. Now, the precision with which they have to communicate that new location depends on how important it is that they move to one particular location. So if you're one of those dwarf species, it doesn't matter. You can just go to a particular bush somewhere, which is shaded, where there are no predatory ants. So you just have to say, well, if we just fly sort of in that direction, then we'll find something. If you're one of those giant honeybees and you need this particular structure because otherwise you can't build your nest, then you have to be a little bit more precise. You have to say, well, if you go in that direction, you will find this massive tree that has a lot of branches on it, and then we'll find a particular branch there. So they have to be more precise. If you have to say, well, we have to go to this particular tree because there is a particular hollow in this area of the tree, like the bee that we have in the US and Australia, then your dance has to be as precise as possible. So that's what I figured out with a large team of other researchers and students, that the precision of the dance is fine-tuned by how difficult the problem is that they're trying to solve, being how precise do you have to be in your communication to be able to find that potential nest site. So I guess that was always sitting in the back of my mind, that communication, the precision of communication is shaped by how important it is to communicate precisely. The same is found in ants. So ants are thousands of different species. They all have their particular ecology, and they all have different ways of communication, which again, you can sort of divvy up in broad categories. We have the ones that live in very large colonies that form those trails. They are the annoying ones. You spill sugar in your kitchen, you don't clean it up, and then you have this massive trail, and it takes you ages to get rid of them. So they basically lay a pheromone trail that says, go in this direction, go in this direction, and they all do the same. And they can do it because they live in colonies of thousands of individuals. So they have a lot of ant power to form those trails. Then the ones that live in very small colonies, they have more direct communication. So again, they say, come and follow me, I found something interesting. So they have to have contact between individuals in order to be able to tell them where the food source is. So again, you can map the ecology on the way in which they communicate. So I guess that's how I started thinking. We have our early ancestors 4 million years ago that came down from the trees, found themselves in an extremely dangerous environment, now have to hold babies, makes them even more vulnerable. The best way to protect yourself is to stick together in social groups. If you live in a social group, as I said earlier, we have to have a form of communication, which can just be simple grunts. Doesn't have to be anything sophisticated at all. But then by the time our species came along and we were faced with this immense problem, how on earth can we keep those tiny babies alive? How on earth can we look after them for about 15 years? It's too much work for one individual, too much work for both parents. We need to ask for help. How do you ask for help? By evolving some sort of form of formal or more precise communication. And at the same time, that precise communication was possible because it starts with the babies who are so neuroplastic because they're born so early. The brain is basically not finalized, not finished, which basically makes them sponges for information. So then you have this feedback again. The need for precise communication, the ability for precise communication because of the changes to the throat, the ability to learn because of this plastic brain. So it all starts with bees, clearly, and then you end up with humans.
Yeah, speaking of bees, I was reading one of your papers called Busy as a Bee or Not. And then you're talking about a large number of bees that are lazy, but it's a kind of a funny expression. We always hear the expression, busy as a bee.
Yeah, well, they're quite like humans in that respect.
In your book, I was in this section, but you say that this brings me to an often posed question. Are we still evolving? So, I mean, as you specialize in evolutionary biology, you must get asked this a lot, as you mentioned in your book. So what do you say to people that ask you if we're still evolving?
Well, we're an extremely young species. So we've only been in existence for about 300,000 years, which, of course, sounds like an enormously long time, but in evolutionary time, that's nothing. So we're extremely young, and to then sort of think that we're outside of evolution for one reason or another is rather bizarre. I guess what people are really getting at is the fact that because of cultural evolution, we have more control over our own lives than, say, a mouse does. So a mouse comes into existence, it grows up, it finds a mate, it mates, it produces more mice, and it goes on and on and on and on. So the mouse can't actually sit down and think, well, when will I have children? Shall I have children? How many children will I have? So it's true that many of us, but also don't forget, there's a large number of people on the planet who have no control over their reproduction either, because of a large number of reasons. So we do tend to be biased by our own lives, thinking, okay, I can use contraceptives, or I can have 5 children, or whatever. So does it then mean that we are no longer evolving because we have some sort of control over our reproduction? But the fact that we have some control over reproduction as a species doesn't mean that we're not subjected to natural selection. I guess another reason why people think we're outside of nature is because we have medical assistance. We often no longer die of things that we used to die from, etc. But there's very simple evidence for natural selection still, or the fact that we're still evolving. For example, with all this whole genome sequencing, when the Neanderthal genome was compared to the Homo sapiens genome, the Denisovan genome was compared to the Homo sapiens and the Neanderthal genome, you can find particular regions that were clearly selected for in particular species. And you and I, because our ancestors came from Europe, because we're white, we have chunks of Neanderthal DNA in us that clearly have been selected because they gave our ancestors a particular advantage. The same is true for people from certain parts of Oceania, in the Aboriginals in Australia, but also people from other places in Southeast Asia. Their ancestors mated with Denisovans, and we can find chunks of DNA in their DNA that come from Denisovans. So that clearly gave those individuals, or the ancestors to those individuals, a selective advantage. In people that live at high altitudes, you can find particular chunks in their DNA that gives them a benefit. They're in the sense that they are able to deal with low oxygen levels. Inuits have particular genes that have been selected for that prevents them from getting cardiovascular diseases, despite having a diet that's really high in fat, because they basically eat blubber most of the time. So wherever you go, you can still find evidence of natural selection acting on particular genes, which means that, yes, we are still evolving. So the answer is yes, but also, yes, we are still evolving because we're a young species, because there's evidence in our genome, and there's no reason to believe that something stops us from evolving. But I understand the question because of the control that we have over our life, over our reproduction, that is unprecedented, that has never happened in evolution.
You're kind of in the same section. You talk about the Flynn effect, which is basically how every generation has gotten smarter than the previous generation. But now we have the actual reverse Flynn effect, which happened around, you mentioned the 1990s. I've read other papers that say the same thing, which means current generations are becoming less smart than the previous generation, aka like the movie Idiocracy, right? Where people are getting dumber. Since 1990. And in your book, you say perhaps it is the reliance on certain kinds of technology that is now becoming a problem. And now we have ChatGPT. Of course, 1990s is kind of the release of the internet, the smartphones. You don't have to memorize anything because you just Google it, or now you ChatGPT it, use Perplexity, use Grok, whatever. So if the Flynn effect started taking effect in the 1990s, at the doorstep of the internet, what do you think? Are we going to see like an exponential reverse of IQ with ChatGPT? Where, I mean, I live in a college town, and I talk to college students all the time, and they're like, "Oh yeah, I use Chat for all my assignments." And I was like, "Well, do you care not about learning anything?" Like, of course not. I'm in school to get a degree. I'm in school to get a job. I'm not in school to learn. Especially at that age, there's more time to party, more time to hang out with friends. A lot of them still take remote classes, which I'm always shocked. I'm like, but COVID ended years ago. But this, the universities kind of figured out that it's just cheaper to run these classes online. And so I'm like, do you even attend the class? Because I was talking to one of my friends who's just hanging out. I'm actually talking to my friend at the pub. I go, yeah, I'm in class right now. I'm like, you're in class, right? I'm like, oh yeah, it's online. I'm like, okay, should I buy you the next round? Is that how we we roll? But like, I mean, what do you have to say? Because I think the Flynn effect reversing in the 90s, the timing is suspect with all the digitalization of the world. And I just would imagine with Chat and various AI tools that it's just going to speed that up. Or do you think I'm wrong on that?
No, I don't think you're wrong on that. And what you just said is really disturbing, I think. The idea that young people don't see learning as something that's actually important, that it's more important to get a degree. They're not at university or college anymore to form the bonds that we did. And universities, of course, have just allowed it, because if they, as you say, putting classes online is much cheaper. So COVID necessitated a change, but none of them, I think, have gone back to forcing students to be in class. But even when I was at university, actually, lots of students never showed up. And then they were surprised that they failed the exams. Whereas I thought, if you just had shown up, made notes at lectures, then you didn't have to do a lot of learning to pass the exam. So I think that's very disconcerting, because, as you say, they probably think, well, first off, it's a trade-off. You can't party and learn stuff at the same time. But it's just this notion of you don't have to know anything anymore because you just find it on the internet. What are you going to do when there's a power failure? I mean, I live in an area where we often have power failures. And actually, not that long ago, the whole internet was out. And then my husband and I were realizing, hey, there's all these things we can't do anymore because we don't have internet. We can't book flights. Basically can't do anything anymore. We're so reliant on the internet. So I do think. So can you recall your bank number, for example? I used to be able to memorize all the important phone numbers that I needed because we just had a dial-up phone. I remember my bank number. I could just go to the bank and you just had to give them your bank number. I didn't have a bank card, primitive enough. But all these things I can't do anymore either. I have difficulty remembering my own phone number, also because it has changed so many times. It's laziness more than anything else, I think. We just feel that we don't have to remember things that we used to. The other thing that I think is very disconcerting, which I've been reading about and hearing about, is the lack of interest in reading. The people, young people in particular, just don't read anymore, which means their language skills will go backwards. So, for example, my best PhD students in the sense of writing papers were the ones that loved reading because they have a sense of style, as Steve Pinker mentions in one of his books. If you're not exposed to the written words, I think you'll never be able to write it as well as someone who does have an interest in the written word. So that's a particular skill, writing. But also reading is so important for your imagination. It's important to grasp ideas, to think about those ideas, to put them in context. And I think all these things we seem to be losing in the Western world, which is disconcerting, because don't forget the Flynn effect it's only measured in Western countries. So you can't say that it's a universal human trait. It's a phenomena in Western countries, which just aren't doing that well anymore when it comes to education.
This is a quote I'll kind of read from your book since we're talking about AI and whatnot. But you say in the book that perhaps the horse has already left the stable. To my dismay, I found a disturbing suggestion in the New South Wales Australia Handbook for Judicial Officers under the heading Technology Supporting Judges. I found a mention of transhumanism aimed at improving the human condition through applied reason, especially by developing and making widely available technologies to eliminate aging and to greatly enhance human intellectual, physical, and psychological capacities. Someone is clearly thinking big, but what follows is scary. The handbook suggests that judges of the future should interface their brain directly with computer memory and AI to increase their intelligence and memory, increase their ability to manage and process information, and reduce the occurrence of fatigue. I think you say you wish. Actually, I think no one should wish anything like this. But then it kind of goes back to what we're talking about. Like maybe in the future, people are going to have the average IQ will be 60. So you're going to have to interface with with the AI just to get you back up to like a reasoning level of cognition or something based on, in developed countries. And one of the big things I never actually thought about that you talked about in the book was where you mentioned about, when you have, what gives AI kind of like the human-like characteristics to a lot of people is the fact that Siri or whatever. I mean, actually, I don't have Siri, but I imagine when you talk to your phone, it's giving you this human-sounding voice, so you're able to kind of like identify with the AI or whatever that you're talking to a human when in fact you're not. But when we kind of take these AI tools and we humanize them, then it's easy to be like, oh, this thing is really smart. It's like my friend you kind of mentioned in the book, Ava from Ex Machina, right? Where it looks, it has a human face and it has a human voice. And so if you just were to kind of switch the voice, make it sound a little bit more robotic, I think people wouldn't be necessarily, as say, infatuated. Like you're not going to be dating your AI bot if it sounds, say it has like a speech impediment or something like that. Like not saying that we need to give our AI a speech impediment, but I think it might create some distance there. But I don't know. I mean, if we're going to have the Flynn effect, maybe we do need to augment, human intelligence. I'm not saying I think we should, obviously not. I agree with you, but it's a double-edged sword. The more that you make people think less, the more you need to actually increase the artificial intelligence. Like you got to have this balancing scale effect.
Yeah, you're right. So did you ever see the film Her? I think it's called Her, where
No, I've watched it a couple times. I've started it. I never could get into it. I never completed it.
So he falls in love with his system. Yes, which is quite interesting. But also, I mean, and that's a fictional film, but not that long ago, I think it was in the US actually, a teen killed himself because his best friend, which was AI, said that it was the best way out for all his problems. So that's what you say when these AI things speak like us. we tend to see them as human, even though they're just a bit of code. And then I think it's very scary, especially for young people, young vulnerable people who don't have the social network around them. And then the other thing is they won't get the social network either because they think they've found friends in pieces of algorithm. So that is scary. And Australia is actually the first country that's banning the use of social media for kids under 16. I'm not sure if it's in place yet, but that's definitely the plan. How they're going to enforce it is, of course, a completely different matter. So do we need judges that are partly AI? I think we should stop before that becomes a necessity. The trouble is, I don't want to say that AI is all bad and evil. I mean, I use it myself, but the trick is to use it in a particular way. And also keeping in mind that it's nothing special. It is something that's copying all the stuff that we humans have done. So it's based on what we have done. It can't create something totally new. So I was reading an essay by an author. She's an Australian author. And she's basically saying, well, because there's a court case that has just been settled in favor of the Australian government. So the big AI companies basically wanted access to all the creative material created in Australia to train their AI. And the creators got together and said, no way, this is our stuff. We have copyright over what we produce. You can't just go away and steal our stuff and use it to make money without our consent. And that's just been one, I think. So that's an important step, I think, that we don't give AI access to just basically everything it wants, or AI. It's of course the big businesses that are creating those algorithms. Where was I? I've lost my train of thought. Yeah, so it's nothing special. It's using what we have created, and it's basically a very quick way, because I find it amazing when you use AI to look up something, it quickly gives you the sources, and it quickly gives you a sentence to indicate how it's putting all that information together, which sounds extremely impressive because it is. I mean, it can think much faster than we can. But then often when you read the precise text, it puts words together that don't really make much sense. It comes up with things that, well, a human being, or a critically thinking human being, wouldn't. So yes, it's a good tool, but if people think AI can replace humans, and that is a very scary thought, I think, because it will be the kind of humans that, well, basically can't think for themselves. That's what I wanted to say, the essay about this Australian author. She said, what AI does, so the training models basically our statistical models say, well, this word is often followed by this word. So then if you use that word, then there's a high probability then that other word will be used. So what you basically get is language that is not creative, because it's basically taking the average of the way people use English, for example. Whereas, of course, if someone is writing a novel or a poem, they try to come up with something that is different, that is not just your average way of using language. So that was her argument, saying AI can never replace humans in that way. But of course, it can pretend to be a kind of human friend, even though it isn't. And that's very scary, especially as I said, for teenagers.
So today's guest has been Madeleine Beekman, who is the author of the new book, Origin of Language, How We Learn to Speak and Why. So there's two final questions for you. One, just is where can people find your new book, Origin of Language? And then secondly, leave us with a final thought on this podcast related to language, maybe something that we didn't talk about that you want to discuss, or just a concluding thought that we can use to wrap up this podcast?
Well, the book is published with Simon and Schuster. So either you can just Google my name and the origin of language, and it will take you to all the platforms where you can buy the book, or you can go to Simon and Schuster and find it there. So that's probably the easiest. A final thought. One thing, so we already talked about something that's disconcerting, the fact that young people are no longer interested in learning. The fact that universities are going with the new zeitgeist because it's cheaper than actually interacting with students. But it starts much younger. What I find very depressing is when I see people with their young children, for example, they go out for breakfast or dinner or even on a playground, and they don't interact. So the kids are given an iPad or a phone or some sort of screen to play with so that the kid is entertained and the parents don't have to be concerned about interacting with their child. If we do not interact with very young children in a very normal human way, then that's how we start getting into serious problems. Their brains will not develop properly, their language skills will not develop properly. If we don't encourage them to read, they will never be able to really master a language the way they should. They basically will not turn into the wonderful human beings that we are supposed to be.
Yeah, it reminds me of the section in your book where you're talking about, I forget the name of the bird, but there was a bird that was endangered, going extinct in Australia, and they were able to kind of repopulate in, say a controlled setting. And then once they released the bird into the wild, they weren't able to mate because it didn't have the proper song that attracted the females. And when you're a toddler and a little kid and you're spending all your time behind a screen, and then you get out into the world, I mean, I guess it's no wonder that children have developmental issues or I should say on the spectrum of ADHD or autism or whatnot. Like for autism, you either have it or you don't. I mean, there's really no such thing as a spectrum, but it's easy to, I think, use that to cover up some developmental issues that children have.
Yes, I think you're right, because many of those developmental issues are like, or the inability to have normal social relationships, and that starts from the moment they're born. And I mean, so yes, the regent honeyeater is the bird that you're talking about. I think it's just a wonderful example where they try to do the right thing by bringing in many of those birds into captivity in zoos, breed them, and then it turns out that because they're not raised with their normal species, they don't sing in the right way. I mean, in a way, it's sort of hilarious. You could make a Monty Python slapstick out of it. So a bird's raised in a zoo, doesn't use the right song, and therefore the females in the wild will say, "Oh, I'm not interested in you because you don't talk right." So now they actually have a program by which they expose them to songs from the wild by recordings, so that the boys can learn the right song when they go out and attract the right females. So again, it's not unique to humans at all, but we do have the unique ability to change our behavior to make sure that the next generation, that our children do grow up, that our grandchildren do grow up in a normal social environment where they learn language, where they learn how to interact with other people. Because that's another thing. If you just sit in your basement talking to your friends, which are not even human, you don't have to look them in the eye. You can't read body language. I mean, how important is body language in all our communication? So someone can use words that are completely contradicting their body language. So this doesn't work. You don't want to tell me the truth, or you're actually angry with me, but you don't want to tell me that I'm angry, etc. It's so important for all our human interactions to be able to, have human interactions with actual human beings. And that needs to be done the minute a baby is born.
My dear friends, that is it for this episode of El Podcast. Once again, if you're not yet subscribed, please subscribe on YouTube as well as Rumble. You can also find us on Spotify and Apple Podcasts or wherever you get your podcasts from. We thank you all from the bottom of our hearts for watching and listening, and we will see you on the next episode.